All right, so our last little step with this is to, of course, look at our graphical representation. So in this case, we've got a graph. Um, they didn't give us any more information. They did talk about this toolkit, so we'd actually have to pull something out. But we have two steps for something like this. If I were to give you a problem like this, one is to identify the parent graph. What family of functions does this come from? So in this case, we are definitely looking at a square root function, right? F of x is equal to the square root of x. Think of it as a radical function or the square root function. Um, we could even write out what that is and then make a table so we could get there. But we've got the algebra now. We could make a table if we wanted to, looking at some of these points, right? We can see -1, -3, -2, 0, 1, 1. So you do have points if you like the table. But we're just going to look and see what happened. Our typical square root graph does this. So we can see two things seem to have happened to our parent graph. We have shifted it down because the starting point is at -1, not 0 when it comes to our y's. And we've also shifted it to the left. So we have it down 1, and then I'm going to use a different color for the left. Left, oh, that's not a different color. Left 3. So we can do both those things in our actual parent function. So now we now know our f of x, which this is. So I shouldn't have really called this f of x. Let's call it g of x. F of x, it's got a square root of x. Inside the square root, that's about left and right. That's about manipulating my x. We want this to move left 3, and we know that that means that we're going to do the opposite. We're going to add 3. And for our down 1, that happens on the outside. We're going to do a plus 1. So there is our there is our function for what is graphed there on the screen. And as always, we can use Desmos to check out and make sure that this is true.